In this video, we're going to be looking at trigonometric identities. So these are just identities or terms or expressions which relate trig terms together. So we looked at sine, cos, tan, right? So there are some equations which actually link them together. So you don't need to know this derivation, but I'm just going to show you where they come from. So if I was to draw a graph and I drew a circle and the center is at the origin, and then I label a point, let's say I label this point here. Okay, and this point is going to be x comma y. So I don't really know what the point is. It's just x comma y as a coordinate. And now I'm going to draw a line like this. So first circle equation we learned during the circle is that the general equation is x minus a squared plus y minus b squared is equal to r squared, like this, right? But if the center is at the origin, then a and b are 0, 0. So this simplifies to x squared plus y squared is equal to r squared, like this. Right, so for the radius, I'm going to say the length of this is just 1, okay? Give the radius as 1. And so now, if I draw like a line here, this now becomes like a right angle triangle, which I will draw in a bit bigger, like here. Okay, so this is now 1. And so the height will be like the y value, right? So we're going to call this y, and the length or the base will be x. And I'm going to call this angle theta, like this. The reason why I've done this is now I can introduce sine and cos, right? Because sine theta we know is equal to opposite over hypotenuse. In this case, opposite is y over hypotenuse is 1, so sine theta is y, sorry. Same thing with cos theta is adjacent x over hypotenuse is y, 1. So therefore, what I can say is, well, x squared is just cos squared theta and y squared is sine squared theta, which I can plug back into here. So I'll get that sine squared theta plus cos squared theta is equal to r squared, and r we set as 1, right? So it's equal to 1. So this is where our first identity comes from. And it's a way of linking sine squared and cos squared. This is the very basic identity that I'm going to learn, and it's very useful for later on. So you need to be very, very well rehearsed with this and very familiar and comfortable with this identity. Right, the second one is tan theta. So tan theta is going to be opposite over adjacent, right? So in this case, y over x. And y we said was sine theta and x was cos theta. So tan theta is actually going to be just sine theta over cos theta. Okay, so once again, this is also a very basic identity that you need to be very well aware of. And as I said, you don't need to know how we got these identities, but it's just showing you where they come from and showing you how this is a basic one. We're going to look at more difficult ones in later chapters. Okay, so using these identities, let's do a bit of simplification. So in this case here, we're trying to change everything in terms of sine theta if possible. So let's try for A, right? So we have cos squared theta, and we want it all in terms of sine squared theta, or sine theta. But we know that, well, sine squared theta plus cos squared is equal to 1, right? So therefore, cos squared will just be equal to 1 minus sine squared theta. Simple as that. Let's try another one. So let's try maybe D. So we have cos theta over tan theta. Let's simplify this a bit. So we know cos theta, that's just cos theta. Tan theta we learned earlier was sine over cos, right? It's going to be sine theta over cos theta. Which means what? We're going to have cos theta times by cos theta over sine theta, which will give us cos squared theta over sine theta. Now we know that cos squared, once again, from part A is 1 minus sine squared, so I could rewrite as 1 minus sine squared theta over sine theta, like this. Okay? It's just a matter of just replacing everything in terms of sine and cos, from cos or tan. One of the trickiest topics which students struggle with when it comes to trig is looking at proving, okay, so proving identities. So in here I have a couple of questions where we have to prove that something is equal to another thing. And these are called identities. First things first, when you were doing this, what you should notice is actually in the middle is rather than equals to sign, right? You get the triple equals to, or three lines, right? This just represents an identity. And for an identity, what it means is we can't move things from left to right. We can only deal with each side separately. When we have the normal equal to sign, we could like multiply and divide back and forth, right? Plus and minus back and forth. When it's three signs like this, it means an identity, so you can't move things left and right. We have to deal with each side separately. So these are all proof questions, so we have to prove that one side is equal to the other side. Okay? And so when we're trying to do this, the general hint I always give my students is always change it into the basic forms sine and cos if possible. Okay? And then you'll see that things will cancel out. Another hint is always make it into one term. So what I mean by one term is, if we have a fraction, we can always cross multiply to make it into one fraction, right? Or if you have two terms, you want to try and factorize it into one fraction, one term as well. So that's the two hints that I always give my students to try and follow, and in most cases, this will allow you to prove most of the identities. Let's try a couple of these questions. So let's try maybe A first. So we normally start off with left-hand side working by LHS. So it's sine theta plus cos theta squared. And our goal is to get the right-hand side, okay? So as I said, you can't move left and right, you just have to deal with the left-hand side only. So from here, what we can do, well, it's squared, so I can expand this, right? So I get sine squared theta plus 2 sine theta cos theta plus cos squared theta. What you should notice is sine squared plus cos squared here is 1. We learned that earlier, right? So that's going to be 1 plus 2 sine theta cos theta, which is equal to the right-hand side. So we've proved it correctly. So this is how you would set out an exam example question. Let's try something else. Let's try maybe C. So we have left-hand side, which is equal to tan x plus 1 over tan x. So this is where the tip comes in, right? We have two terms here, right? So we want to ideally make it into one term, and we do that by making it into one fraction. So for the common denominator, this has to be tan squared x plus 1 over tan x. Now finding the next step might be a bit tricky, but then, as I said before, you want to change everything into sine and cos if possible. So I can change these tans into sine and cos. So tan squared is just same thing as sine squared x over cos squared x plus 1, and that's all over sine x over cos x. Right, what next? Well, the numerator is also technically two different terms, right? So I can make that into one term as well. So that'll be sine squared x plus 1 over cos squared x, and the denominator I'm just going to leave as sine x over cos x. I can simplify fractions by dividing it, so it'll be sine squared x plus 1 over cos squared x multiplied by cos x over sine x like this. Okay, and we can do some cancelling out, right? So this will cancel out with one of these. Okay, and so you're left with sine squared x plus 1 over sine x cos x. Right, so what do we need to get? So if you look back here, they're asking us to get 1 over sine x cos x, right? And so what you can see is, well, sine squared x plus 1 is what? Okay, so let's try another one here. Let's try question C. So we have left-hand side is equal to tan x plus 1 over tan x. So as I said before, if we have two different terms, we want to try and make it into one term. So we can make it a common denominator and change it to tan squared x plus 1 over tan x. Now it might be tricky to see where we go from here, but as I said before, we want to change everything to sine and cos if possible. So tan is just sine over cos, right? So that's what I'm going to do. Tan squared is therefore sine squared x over cos squared x plus 1 over sine x over cos x. Right, technically the numerator is still two terms, which I can combine into one term. So that will be sine squared x plus cos squared x over cos squared x. And that's all over still sine x cos x. I can now simplify this fraction a bit more. So sine squared x plus cos squared x over cos squared x multiplied by cos x over sine x. Right, what you should realize is now, well, one of these will cancel out, right? And this term here is actually equal to 1, the identity, right, we learned earlier. So in fact, we'll just be left with 1 over sine x cos x, which is equal to the right-hand side of the identity. Maybe you could do one more, so let's try maybe this one here, f. So 2 minus sine theta minus cos squared theta. So left-hand side is equal to 2 minus sine theta minus cos theta all squared. So we can expand it if it's squared, right? So we have 2 minus sine squared theta minus 2 sine theta cos theta plus cos squared theta. Remember, sine squared plus cos squared is 1, right? So I can rewrite that as 2 minus 1 minus 2 sine theta cos theta. And then simplifying a bit more, I get 1 plus 2 sine theta cos theta. Right, as you can see, there's not much to do now, right? But what I can do now is say, well, 1 is actually sine squared plus cos squared, right? If I write it like sine squared theta plus 2 sine theta cos theta plus cos squared theta, then you can see that this now factorizes to sine theta plus cos theta squared, which is equal to the right-hand side that they asked us to find here. Okay. So as you can see, it's just a matter of just being very familiar with these identities and manipulating them. And the general rule, as I said, is make it into one term if possible and always change it to sine and cos. That way you can simplify or cancel out a bit more easily.